Greetings. In this tutorial, we'll go through a quick demonstration of how to apply Service Manager to a controller. Anyone migrating from Zend Framework 2 days, you may have come accustomed to a style where you say this, get ServiceLocator, and then name of the service. This caused a lot of problems since there was no reliable way to tell what service is used in what part of the application. Anyone could randomly bring in a service through getServiceLocator, and changing of service in one location broke unpredictable number of components. Writing tests for this style of code, where you couldn't explicitly make a stub or a mock for the service dependency, was either too difficult or totally impossible. So instead, now you have to specify what dependencies does the object need ahead of time as a definition in a constructor. In previous tutorial, we already defined the concept of a factory and the example of repository, so we're going to go right into creating a constructor for this controller that will state exactly what it needs to do its job. In this example, let's say that one or more action interacts with the repository for users to either fetch users or update users. For now, let's say we have a method called getUserById, and we're just going to return a dummy empty user for this example. For methods to have access to it, the controller needs to have it in the private property. So user repository, it's going to be of type repository from users, and we can see that the user that we're looking for is coming out of the repository getUserById, something in there like that. Now, how do we get this user repository inside of the controller from the Service Manager? For that, since we know that is the dependency of the controller, it means it has to go through a constructor. A construct, and we require the repository for this controller to do its job. And then we assign that repository to its own private property. Of course, this doesn't have to be the component that you create. The exact same principle applies to any Zend framework or any other module that you work with. The main point is that you must explicitly define what objects you use where before you can use them in Service Manager or share them across your module. I already have the service defined in my module. Here I have the user repository actually being created by the repository factory. If you want to use another Zend framework component, you just have to know what is the name of its service. Now that the controller has a factory, the original definition for the router is not going to work, because this invocable factory that comes with the Service Manager from Zend assumes that the class doesn't have any dependencies. So if we try this right now, the site is going to break. So to get that dependency into the controller, we need to replace this with either a function that returns a new instance of the controller or a whole factory. To start with a simpler version, we're going to go with an invocable function, which again, according to the framework, takes in two parameters, the reference to the Service Manager and the name of the service that you want to create. So in this case, the service that we're actually creating is the name of the controller. So it said that we needed a container interface, which is the Service Manager itself, and what we're trying to create, which is the controller name. Let's see exactly what we get. We're going to put a breakpoint. We will refresh the page. And note that we have indeed hit this now custom factory that we have created. We are now asking for the index controller, and we have an instance of Service Manager ready to grab any other dependencies that we will need. We know that this particular controller is our index controller, so we will create it right away. And the IDE is complaining that we're missing the repository, which is this parameter. So now that we have access to the Service Manager, we will do exactly the same thing we've done with Zend Framework 2, which is to say repository equals Service Manager get repository class. And just to make sure that we have non-ambiguous names of things, and we pass that repository into our controller, and things should work again. There we go. The controller now operates, and in fact, if we go here, we see once we start the application, we first go to the constructor, the repository gets assigned, and now when we actually want to get the user, we notice that the user repository is actually a proper instance of it, and we are ready to get the users or whatever other functions we want out of it. This is not a good place to keep this function, however, because one, Zend Framework wants to cache its configurations, and you cannot cache a function. So this is going to actually slow down your application by a lot. And secondly, it's going to be awkward to constantly copy and paste this definition for every single controller that you have in your application and manually identifying the index or whatever controller else you have and bringing in the exact same dependency into it. So I'm going to give it a dedicated factory right where the rest of the controllers are. So this one is going to have a special index controller factory. I will assign the same namespace as the controller itself, so portal controller. Classes index controller factory. And for it to be able to integrate with Service Manager, it needs to implement factory interface. Make sure you pick the non-deprecated new version. And what does the IDE tell us we need to do? Because it's now conveniently telling us that we missed something. I'm going to go into class implementation. And we got an invoke interface that is missing. The invoke interface allows us to use a class as if it was a function. So that makes it exactly identical to what this thing is doing. So we move this out into here. And I call it container, I call it Service Manager. And this just needs to be properly imported, which it doesn't want to automatically, so do it manually. ZFT user. Okay, that matches. And let's also match this. And now we need to redirect this to use that newly created factory. Index controller factory. So now Zend Framework can once again cache everything, and we have our dedicated class that's going to be easier to do some more complicated stuff in a little bit. To verify that it still works, put a breakpoint. And here it is. We can confirm that it actually goes there. Continue execution. Yep, right as we were before. And let's put one there instead. We got our user back, and the application turned on just fine. And let's make a note of that in our repository. Put index controller instantiation into dedicated factory class. So the question of the day is, am I going to create a new one of these factories for every single controller I have in my application? That's actually a very difficult question to answer, and that's where your architecture skills are going to come in. Let's create another controller and another route to illustrate a couple of examples. Let's say that we're going to make an admin controller. Usually I wouldn't do that. I would actually make an admin module altogether. Let's just do this real quick. Put admin controller there and give it a route. Let's see, what can we put? We can make this duplicated probably. Admin, little class, admin. We're going to go towards admin. Actually, I haven't changed this yet, so this is going to be an admin as well. Index, module, controller, admin controller, class like that. Now that is not an actual class. This is just the name of a class, right? This : class only returns a string name of the class, not an actual instance. So all this is saying is that there is a controller that's going to be called an admin controller. It's only going to be called that. So its actual instance needs to be defined. Where is the instance for this name coming from? Let's say that we want to reuse the index factory and see how that's going to affect us. So back to the site. I'm going to go towards admin this time. The breakpoints take us right back to the index controller factory, which is good because that's the one that we're reusing. And of course, it takes us to the index action. But notice an additional little feature. In that inner factory, we are also given the name of the controller that was actually been requested. It's just that right now we're not using it. So let's use this as a clue to figure out whether we want to make new ones of these factories for every single controller, or what kind of rule can we define to reuse this factory in as many places as possible? Well, the honest answer is only time will tell which one is better. Only when your application grows beyond a couple of controllers, whatever number of tens of thousands of lines, will you really know what it is that fits your needs properly. If all of your controllers happen to have different dependencies, then the answer is very straightforward. Just create a new factory for every controller. Otherwise, you might have to go through a more complex categorization of your controllers, where you define a category per group of controllers with similar dependencies. Let's say for this example, the index and admin controllers have one thing in common, which is they are user-related controllers. They are both going to deal with something with the user repository. One is going to bring in details of the login user, and admin controller might want to have a list of all users in a system and adjust all of their properties without restrictions. So that sounds like this factory should probably be renamed into something more meaningful, such as user-related controller factory. Not the best names, I'm not exactly proud of it, but the best we can do in a limited application like this. You can tell much better what your categories are for your factories. And here the IDE tells us that we should do quite a bit of renaming. We will verify that it has done a good job renaming the controllers here, the controller factories. And having done that, we can now, instead of saying exactly the name of the controller instance, we're now going to create the instance based on the requested name. So just like this, PHP is capable of creating object instances simply based on a string value. So let's look at that. Let's put our breakpoints. We got one here. We're going to put one in the admin controller, and then make sure that we still have one in the index controller. Admin. We're going through this factory, and we got into the admin controller. Very good. That's exactly what we expected. And it's just complaining about the renderer. We don't care about that right now. And if we go back to the original index, then we once again go to the factory. And now we're at the index controller because this factory was able to give the proper request name as an instance. I should probably rename this to something more meaningful, such as controller name. No, not quite that deep. Right now this is not reliable, however, so if we do something silly like we try to do the admin class manually, hey, we have an admin controller, and we try to go towards admin controller. That's a typical mistake to make. We'll go back to admin, and this is going to fail spectacularly. We got a fatal error, and we can't even tell what happened from this cryptic message. To prevent these cryptic messages where you cannot tell what in the world happened just now, we will throw exceptions where we know there are potential instabilities to give framework hints to give us better results, so we have something easier to troubleshoot with. One thing we somehow didn't get from PHP Storm is the list of exceptions that this invoke function is capable of throwing. So we're going to add them here, but it has already imported them in a namespace conveniently. So that's very good. We're going to take advantage of them. There are three possible bad things that can happen here. We have the service not found, where we have requested a service that doesn't exist, something like what happened just now. A service not created exception. We're going to throw that if our constructor has failed for whatever reason, so please throw those in if your constructor can potentially fail. And a container exception if you can't decide which one of these two to use, or it's something completely else different. As we have seen, our problem is there is no such controller name, or therefore there's no such service name that we're trying to call. So just before we run any of this, we're going to verify whether the controller name that we want actually present. So if not, class exists, controller name, we are going to throw a new service not found exception. What does it want? It wants some kind of message, and we're going to say requested controller name does not exist. Nice. Because this is an exception, the program will actually not go beyond this line. So let's make sure we actually go there. So now we're actually going towards the exception throwing because this class indeed doesn't exist. And when we let it go through, we see we have such a nice message when we do it this way. We're even told where exactly this happened. It tells us, hey, you need to look at the user-related controller factory invoke method. Something has gone really bad there. So we're done. Some final thoughts. This didn't have to be a factory. This could have been an abstract factory, which gives you a slightly better control over how you create objects. If this doesn't cover all of your cases, you have a more difficult combination of reusable dependencies versus unique dependencies. Maybe you can play with inheritance of this factory, maybe have a common one with the similar dependencies, and then the unique ones or variations of those, you can extend that, and then instead of having it in the invoke method, perhaps you can put them in some kind of private or rather protected create controller something, and then the invoke will do this create controller, and then the create controller can have the module or controller specific or even route maybe specific configurations. You can get really creative with all the ways you can define dependency lists for the controllers.